Right, hello students, welcome again to another lesson for maths. Today we'll be continuing, as a matter of fact we will conclude the lesson we've been having on inequalities today, and we'll be looking at how we solve linear and quadratic inequalities. Okay, if you're ready, let's begin. Now, I gave you a couple of questions last week to solve as homework. We'll go over those questions on solving linear inequalities and then move on to how we solve quadratic inequalities. But before we do, I want us to go over the basics, what you need to have at the back of your mind before you start solving any linear inequality, be it linear, I should say, or quadratic inequality. There are some basic facts you need to be aware of. Okay, so we solve linear inequalities just like we would any equation. All right, but I want you to take note of the bits of written in red and in underline. Remember, when both sides of an inequality are multiplied or divided by a negative number, the inequality is reserved. Alright, so we not only will proceed as we're solving any given equation, but the moment you divide or you multiply by a negative number, the inequality sign will automatically change. And I'll explain what I mean by that shortly. For example, if you have minus 4x is greater than 12, alright? Now, of course, to get x here, what do? Can anyone guess? You divide both sides by minus 4. Exactly, divide both sides by minus 4. Divide both sides by minus 4. And you can see, because we're dividing by a negative number, the moment you divide by a negative number, the inequality sign will be reversed. It's originally greater than, but because now we're dividing by a negative number, the inequality sign has now changed from greater than to less than. That's why, of course, I've changed the color, just to see where the change has taken place. Alright, due to the fact that we're dividing by a negative number. Okay, and so that we'll cancel that. The 4, we'll cancel the 4 as well. You're left with just x on the left hand side. And then the negative, minus 4 goes in 12. That gives you minus 3. Alright? And then you have, as the value of x will be less than minus 3. Okay, but what I want you to really take note or pay attention to here is the fact that the inequality sign has been reversed. What I mean by reversed is, you can see we started with greater than, and now it's been reversed to less than, because of the fact that we've divided by a negative number. Okay, and the same also happens when you multiply by a negative number. So take note of that. Everything else will be as you normally would when you're solving any given equation. Alright, but when you have to divide or multiply by a negative number, that will automatically change the inequality sign. So take note. Alright? So, as you can see here, x is now less than minus 3. Inequality sign has changed, or the inequality sign has been reversed. Okay? Now, moving on. In addition, okay, the inequality sign is also reversed when you change the sign of the unknown variable. What do I mean by that? Let's see an example. For example, if you have that 7 is less than or equal to t, now of course it's normally the case that you put the unknown on the left hand side. But here, as you can see, the unknown is on the right hand side. So if you want to move the unknown from the right hand side to the left hand side, which is where it normally should be, that will affect the inequality sign. So when the t goes to the left hand side, which is normally where the unknown is put, and that goes to the right hand side, the inequality sign will change. Watch. So you have t will be greater than or equal to. Originally, the equal sign is less than or equal to. But once the t, they're known, once it goes over to the left-hand side, the inequality sign now changes. And that's why I've used a different color here to emphasize the change. So the inequality sign now changes to greater than or equal to, greater than or equal to 7. Alright? And of course, the representation is better this way with the unknown on the left hand side rather than on the right hand side. Okay? So the inequality sign is reversed. You have t is greater than or equal to 7. So take note of these two very important cases where the inequality sign changes in your calculation, where you're multiplying or dividing by a negative number, and of course where you need to move the unknown from the right hand side to the left hand side. Alright, so have that at the back of your mind when you are solving any given inequality, especially if it's a linear inequality. Alright, so now I want to very quickly go over the question I gave you as homework last week, and if you did it, I want you to go over the corrections together, and let's see how many of those 7 questions you managed to get right. For those you didn't get right, don't worry, just take down the corrections and make sure you understand. So very quickly I want us to go over these and move on to the quadratic inequality, because that's the bit I really want us to concentrate more on. Alright, linear inequalities, well, not much of a problem for most of you, if not all of you, but the quadratic, some of you might struggle a little bit, because there are some aspects that if you don't understand very well, you may struggle trying to solve any given quadratic inequality. Alright, so let's quickly go over the solutions to the questions I gave you last week on linear inequalities. Let's question number 1. You have 7x minus 3 is greater than 32. How you solve that? Like I said, you carry on like you normally would if you're given any equation. So you imagine for a moment when you've got the greater than sign, imagine you've got the equal sign there. So just go ahead and solve as you normally would. And how you do that? You collect like terms. You keep the unknown on the left hand side and then move the constants to the right hand side. And then not forgetting the fact that once you move from one side to another, the sign will change. Alright, don't forget that too. So you have 7x will be greater than 32. Now you move the minus 3 to the right hand side and that becomes plus 3. Okay, I'm sure you know that. That's what you would normally do if you had an equal sign there. Alright, and so moving on, you now have 7x will be greater than 32 plus 3 gives you 35. And from here, to get x, what do? You divide both sides by 7, exactly. When you divide both sides by 7, now of course remember, 7 is a positive number, so that does not affect the inequality sign. It stays the same, it doesn't change. Okay, so the 7 will cancel the 7 and you left x is greater than 7 and 35 gives you 5. And there you go, x is greater than 5. But then the integer values, you've been asked to write down the integer values that will satisfy this inequality. So when you have x being greater than 5, remember you will not include 5. So any value of x greater than 5 will be acceptable. And we're thinking of values like what? 6, 7, 8, 9, 10 and so on. Exactly. So the values of x are, as you can see, 6, 7, 8, 9, 10 and so on. So any of these values of x will satisfy that given inequality. Alright? Well, I hope you got that right. If you didn't, just take down the correction. I hope you can follow the steps. Moving on quickly to question number 2. Again, you have that given linear inequality. You've got 3x on the left hand side and then 8x on the right hand side. What do? Collect like terms. Put all the x's on one side, preferably on the left hand side. You always put the unknown on the left hand side. So let's collect like terms, and when you do, you move the 8x from the right hand side to the left hand side. It will be negative, and then move the plus 7 from the left hand side to the right hand side. And that becomes negative as well. So you have 3x minus 8x. Now the inequality sign stays the same, doesn't change yet. If at all, it's going to change. Greater than or equal to 52, then minus 7. Alright? And so we simplify that. 3x minus 8x is what? Minus 5x, that's right. and then less than or equal to 52 minus 7 gives you 45. And so from here, what do you do to have x? You divide both sides by minus 5. Exactly, you divide both sides by minus 5. And when you divide both sides by minus 5, aha, we are dividing by a negative number. And remember, when you divide by a negative number, the inequality sign changes. You can see that's why I have a color change here to signify or to draw your attention to the fact that we have a change in the inequality sign. From less than or equal to greater than or equal to, because we're dividing by a negative. Take note. And so that cancels that. 5 cancels that. You left x on the left hand side. And then minus 5 goes in 45. That's minus 9. So you have x is greater than or equal to minus 9. Alright? So if x is greater than or equal to minus 9, what are the possible integer values? X is greater than or equal to minus 9. So you're going to start with minus 9, and then all other values of x greater than minus 9. Minus 9, remember it's a negative number. Minus 9, minus 8, minus 7, minus 6, and so on. Yeah, that's right. So minus 9, that's where you're starting from. And then you proceed minus 8, minus 7, minus 6, minus 5, and so on. You have to be careful when you have a negative number. Be extra careful. Alright, so far so good. Moving on quickly to question number 3. That's question number 3. Now I'll have to pace up so we get to the bit that really matters, which is the quadratic inequalities. Okay? Again, what you do here, collect like terms. And then when you do, you have 6x, that's minus 4x on the right hand side. You move it to the left hand side, it becomes positive. The minus 8 you've got on the left hand side, you move it to the right hand side, it becomes positive. And you've got that. 6x plus 4x is greater than or equal to 25 plus 8. And then moving on, 6x plus 4x, that's 10x, is greater than or equal to 25 plus 8, that gives you 33. Okay, so if 10x is greater than or equal to 33, to get x, you divide both sides by 10. That by 10, that by 10. So the 10 cancels, and you have the x on the left hand side is greater than or equal to 33 divided by 10 gives you 3.3. But then, 3.3 is not a whole number. It's not an integer. Alright? So, if you're looking at the next integer, which is greater than 3.3, it will be what? Integer, remember? A whole number. It will be 4, 5, 6, 7, and so on. Exactly. 4, 5, 6, 7, and so on. So, these are the integer values that will satisfy that given linear inequality. Alright? So far so good. Moving on to question number 4. Now that's question number 4. Excuse me. That's question number 4. You have the brackets. When you use the brackets, open the bracket. You take the 2 on the outside to multiply each of the terms you've got inside the bracket. So you 2 to multiply the x, and then the 2 to multiply the 3. So when you open the bracket, you have 2 times x gives you 2x, plus 2 times 3, that gives you 6, is less than 9x plus 27. Again, what do you do? Collect like terms. You collect like terms, you move the 9x from the right hand side to the left hand side, and then move the plus 6 from the left hand side to the right hand side. Being mindful of the fact that the signs will change. Don't forget that. Alright, so you have 2x minus 9x is less than 27 minus 6. Okay, 2x minus 9x gives you what? Minus 7x is less than 27 minus 6 gives you 21. Aha! So now, to get x, what do? You divide both sides by the coefficient of x. And the coefficient of x here is minus 7. Aha! Negative number. When you have a negative number, don't forget, what do? Do not forget, very important. What do? When you have a negative number? You... Oh, sorry. Right, when you have a negative number, what do you think happens? When you divide by a negative number, in this case minus 7, the inequality sign changes exactly. The inequality sign changes from less than to greater than, because we're dividing by a negative number. So that cancels. The 7 goes and then you left the x on the left hand side, and then minus 7 goes in 21, you have minus 3. Alright, so you have x is greater than minus 3. And when x is greater than minus 3, what are the possible integer values when x is greater than minus 3? You're going to start with minus 3, you're going to start with the next number greater than minus 3. Minus 3. After minus 3, what's the next bigger number? Can you guess? Minus 2, minus 1, 0, 1, 2, and so on. Okay, so far so good. Quickly, let's move on to the next question, number 5. Okay, again, quickly, I just want you to watch and follow. You collect like terms. When you collect like terms, you have minus. Aha! Now, please, I want you to do something slightly different here. Just to show you that you can actually go a different way and still get your answer right. And what am I going to do here? If you will observe, I'm putting the variable to your right now. I want to put the variable to the right, okay? So what do I mean? You move the minus 4x from the left hand side to the right, so it becomes positive, and then move the minus 23 from the right to the left. And so when you do that, that's what you have, okay? And when you add that, you get 18, and when you add that, you get 3x. But then, remember, like I said, you divide both sides by 3 here. When you divide both sides by 3, 3 in 18 gives you 6. And then that 3 cancels, and you're left with just x. And this is what you have. But remember, we always put the unknown on the left-hand side. And when you do that, inequality sign changes. It's going to change from greater than here to, yes, less than. Alright, so you have x is less than 6. And so if x is less than 6, what will be the possible values of x? 5, 4, 3, 2, 1, 0, and so on. Exactly. Alright? So if you did this another way, where of course you have your unknown to your left, you will still end up getting x less than 6 as your final answer. Okay? I just showed you that just to let you know that whichever method you decide to use, you will still end up getting the answer right if you follow the steps and you do it correctly. Alright? Moving on to question number 6 quickly. Well, that's pretty straightforward. 2x will be less than 11 minus 3. 11 minus 3 is what? 8. So you have 2x is less than 8. If 2x is less than 8, what do you need to get x? Divide both sides by 2. When you divide both sides by 2, x is 4. Exactly. And of course, if x is less than 4, what are the possible integer values of x less than 4? 3, 2, 1, 0, and so on. Exactly. 3, 2, 1, 0, minus 1, minus 2, and so on. Okay, so far so good. Now the last question. Number 7 now. Again, you collect like terms, put all the x's to the left hand side, and then the constants or the numbers to the right hand side. And then when you do that, the 7x on the right hand side moves to the left hand side, becomes negative. And the plus 9 on the left hand side goes over to the right hand side, and then it becomes negative. So you have 3x minus 7x is greater than or equal to 33 minus 9. Okay, 3x minus 7x gives you minus 4x. Is less than or equal to 33 minus 9. That gives you 24. Aha! Now again, observe, you've got x. So to get that value of x, you divide both sides by the coefficient, and the coefficient in this case is minus 4. And so when you divide by the coefficient, remember, the inequality sign will be reversed. The moment, the instant you divide by a negative number, the inequality sign changes. So it is greater than or equal to, and then it's going to change to less than or equal to. That cancels that. That cancels that. 4 in 4, you have just 1. So you left x on the left hand side. Now minus 4 in 24, that's minus 6. Okay? So x is less than or equal to minus 6, and so the possible integer values starting with minus 6 because it's less than or equal to minus 6. After minus 6, what do you have? Less than, remember negative, minus 6, minus 7, exactly minus 8, and so on. Minus 6, minus 7, minus 8, minus 9, minus 10, and so on. Alright, so that's that for the homework questions. Let's now move on to the other aspect which I want you all to pay attention to. I want to see how we solve quadratic inequalities, and I really want you to pay attention here. There are some bits of information you really need to take into consideration. Alright, so I have 3 examples here which I'd like us to go over, and if you are able to understand the 3 examples, then you shouldn't have any problems solving any given quadratic inequality. And as a matter of fact, after the 3 examples, I'm going to give you a set of questions as homework which I want you to try, okay, and then give or send your answers to my inbox, okay. So we've been asked to solve the given quadratic inequalities, and there's the first one. X squared minus 6x plus 8 is less than 0. It's quadratic because of that square, and it's an inequality because of that inequality symbol less than. So that's why it's a quadratic inequality. If you had an equal sign there, then it would be a quadratic equation. Okay, excuse me. Right. So, whenever you're given a quadratic inequality, you always start first by solving the quadratic equation. You always start with the quadratic equation. So, it's the same quadratic expression, but now let's solve the quadratic equation where that is equal to 0. Now, of course, when you're solving any given quadratic equation, you can either factorize, use completing the square method, or the quadratic formula, or better still, you can use a graph, alright? But in this case, we should be able to factorize that, and when we factorize that quadratic equation, that's what you get. X minus 2, x minus 4 is equal to 0. And from here, what it means is, or we can actually split it up, break it up, and then you have x minus 2 is equal to 0, or x minus 4 is equal to 0. Now, if x minus 2 is equal to 0, therefore x is what? X is 2, exactly. Or, if x minus 4 is equal to 0, therefore x is what? X is 2, exactly. Okay? So, when you solve the quadratic equation, this is what you have. And I want you to pay attention to the next bit, because that's the bit that really matters the most. So now, for the quadratic equation, you have a sketch which looks like that. So the graph, it will be a parabola which slopes upwards like this because of the coefficient of that. The coefficient is positive, that's why it's sloping like that. So the parabola we call the x-axis at these 2 points, where x is 2 and where x is 4. Alright, so now when does this apply to the inequality? This is the original question now. X squared minus 6x plus 8 is less than 0. Remember from previous lessons, if it's greater, it will be above. If it's less than, it's going to be below. Now, because we are having just one variable here, which is x, we'll concentrate on the x-axis. So, if you have less than 0 here, then it means the region of the parabola below the x-axis. And where is that? Look at the parabola starting from there. That's above the x-axis. But from here to there, this is below the x-axis. So this is our region of interest, okay? So, remember, you have the points 2 and 4, where the parabola cuts the x-axis. Now, because this inequality sign says less than, we will not shape the 2 and the 4, meaning we will not include the 2 and the 4, alright? So take note of that. Therefore, the only integer value of x which satisfies this inequality is between 2 and 4. And when you have the only integer that you've got between 2 and 4 is, it's just 3. Okay? It's just 3. So x is 3, and that's your answer. That's your answer to that inequality. I hope you got that. If you didn't, don't worry. Let's see the next example. Okay? Right, here's question number 2. Yet another quadratic inequality. Okay, you've got a less than or equal to 0. So first thing first, let's start with the quadratic equation and solve that to see where the parabola will cut the x-axis. Okay, so you've got x squared minus 4x minus 5 is equal to 0. So that is the quadratic equation which we need to solve first. And good enough, you can actually factorize this. And when you factorize this quadratic equation, what do you get? You have x plus 1, x minus 5 is equal to 0. And then when you break it up, you have x plus 1 is equal to 0, or x minus 5 is equal to 0. If x plus 1 is equal to 0, therefore x is equal to minus 1 exactly. If x plus 1 is equal to 0, to get the value of x, you simply move that over there. And when you move it, the plus 1 changes to minus 1. So x will be equal to minus 1. Or, if x minus 5 is equal to 0, therefore the value of x will be 0 plus 5. And of course, 0 plus 5 is simply 5. So you have, or x is equal to 5. So when you solve this quadratic equation, these are the two values of x you will get. Meaning, the parabola will cross the x-axis at these 2 points. Okay, and let's just see the sketch for that. So your x squared minus 4x minus 5 is equal to 0. The sketch of the parabola is shown. So there you go. The parabola again is positive. The coefficient of the x squared is positive, so that's why it goes from up there and then right up there again. Okay, the parabola slopes upwards. Okay, and then it cuts x-axis, and at that point it's minus 1 there. Between 0 and minus 2 is minus 1, and then between 4 and 6 is 5. Alright, so now I want to see how that can help us in solving that quadratic inequality. Now you have this greater than or equal to. Aha! Greater than or equal to. Greater than or equal to. Meaning we will consider the minus 1 and 5 because of the equal to. So minus 1 and 5 will be part of the solution. Alright? So that's how you have a solid circle there at minus 1 and at 5. Okay? But greater than, remember greater than will be above the x-axis. So observe, if you start from there, it's above the x-axis, and then when you get here on the x-axis, when you continue, this is below the x-axis, below the x-axis, below the x-axis, on the x-axis, and then above the x-axis. So anywhere here that is to the left of minus 1, and anywhere here to the right of 5 will satisfy this inequality. I hope you all can see that. Okay, so the integer values of x which satisfy this this inequality are as shown. So you have the bit to the left, which is x is less than or equal to, because we're starting there, minus 1, or x is, can anyone guess for the sign, greater than or equal to 5. Exactly, greater than or equal to 5. So when you start with that, what are the possible integer values when you go into that side? You're starting with minus 1, yes, minus 1, minus 2, minus 3, and so on, yeah? So you have minus 1, minus 2, minus 3, and so on. And that side, you have after 5, or you're starting with 5 because it says greater than or equal to, you are including the 5 because the circle is a solid one. So you have 5, 6, 7, 8, and so on. Alright? So far so good. We have one more example to go. Question number 3 now. You have 7 minus 6x minus x squared is greater than 0. Let's get the third and the last example, and I hope you all will be able to follow, because thereafter I have a set of questions for you to try your hands on. Okay, it's important for you to be able to do those questions, because if you're able to solve them successfully and get the answers right, then that gives you the impression that yes indeed you've understood how to solve inequalities, especially quadratic inequalities. Okay, so here's an example here now. Question number 3. It says 7 minus 6x minus x squared is greater than 0. Again, I want you to come up with the quadratic equation and then solve that to get the values of x first. So you have 7 minus 6x minus x squared is equal to 0. So let's solve that quadratic equation. And remember, when you're solving quadratic equation, you put the quadratic part first, and then next the second term will be the linear part, and then the third term will be the constant. Alright, so you have to slightly rearrange this in that order, where the quadratic term comes first, next the linear term, and last but not least the constant. Alright, so when you rewrite this properly, you will have minus x squared, which is the quadratic term, minus 6x, which is the linear term, plus 7 is equal to 0. So now let's see if we can solve that quadratic equation. And yes, of course, you can factorize. If you try your hands on that and you factorize this quadratic equation, here's what you get. You will get x plus 1, x minus 7 is equal to 0. Well, as a matter of fact, there should be a minus here. Sorry about that. I left the minus there, so there should be a minus there. So you have minus x minus 7 is equal to 0, or x, oh well, this is minus as well. Sorry about that. You have to cross-check and make sure that this indeed is correct. Okay, so there should be a minus there. Change that from plus to minus to affect this, and then put a minus there. Okay, so this is what you should have. So this should actually be x minus 1 and minus x minus 7 is equal to 0. Okay, and so when you break them up, it doesn't matter which of this you write first. It can either be this or that. So if you put this first, you have minus x minus 7 is equal to 0, or x minus 1 is equal to 0. And so when you take that, if minus x minus 7 is equal to 0, therefore x will be minus 7. So that's minus x. To make it positive, you move it. So you have 0 plus x, so x will be minus 7. So that's one of the values of x. Or if x minus 1 is equal to 0, therefore x will be, and you move that, x will be equal to 1. Exactly. So these are the two values of x, meaning these are the points on the x-axis where the parabola will pass through. Okay, so let's have a quick sketch now. So given the quadratic part, here is a sketch. So I'm going to sketch it. Now, you will observe that this time it's sloping or going all the way down. And the reason is because the coefficient of the x squared, the quadratic part, is negative. That's why it's going all the way down. But then you will notice that it cuts the x-axis at this point and that point. That point is your minus 7, exactly. So it's minus 7 there. And the other point there is just after 0, the origin is your 1. Exactly. 1. Right there. Okay, so that's that for the quadratic part. Now let's see how that applies to the given quadratic inequality. Okay, so here's the quadratic inequality. It says greater than here, greater than. Meaning at these 2 points, are we going to have a solid circle or not? It will not be a solid circle because it's just greater than. Yeah? It's not a solid circle, meaning we would take into consideration the minus 7 and the 1. We would include the 2 in our answers, alright? So take note. Now, we have greater than. Remember, greater than is above the x-axis, less than is below the x-axis. So you're starting from here. It's below the x-axis. Note that's our point of interest. Or when you get here, it's spot on the x-axis, and then afterwards it's above the x-axis, above the x-axis, above the x-axis, on the x-axis, and then below. But because it's greater than, we're interested in the part above the x-axis, so that region. Meaning anywhere between -7 and 1. Okay? So the integer values of x which satisfy this inequality are between -1 and 7. Okay, like that. Between -1 and 7. So now think of the integers, meaning the whole numbers, between -1 and 7. And remember, we're not going to include the -7 and 1. No, because the circles on these points are not shaded. Okay, so after -1, if you're going towards after -7, if you're going towards 1, let's see the integers you have. The next one after -7 will be what? -6, -5, -4, -3, -2, -1, 0, and that's it. You don't include the 1. So the integer values of x that will satisfy that given inequality, the values are -6. You're not going to include the -7, remember, because it's not shaded there. So the next one will be -6, -5, -4, -3, -2, -1, and 0. You don't include the 1 because it's not shaded there. Alright? And that's your solution. That's your answer. And we are done. Alright? Now, I will give you some questions now. Just 5 questions for you to try your hands on solving quadratic inequalities. I want you to send your answers to my inbox. I'll be waiting for your answers, okay? So here are the questions. So I want you to solve the following quadratic inequalities given the integer values in each case. So I'm just giving you just 5 questions, alright? So here's question number 1. X squared minus 7x plus 10 is less than 0. Next up, number 2, x squared minus 12x minus 13 is greater than 0. 5 minus 4x minus x squared is less than 0. That's number 3. Number 4, 2x squared plus 7x plus 3 is greater than or equal to 0. And finally, number 5, 5x squared minus 12x plus 4 is less than 0. And so those are your 5 questions. I want you to try your hands on those questions and send your answers to my inbox. I'll be waiting for them. Alright? So at this point, that wraps up the lesson on solving inequalities, or if you like, inequalities in general. And I hope that helps. Thank you so much for your time, and I shall see you again. Stay safe and bye for now.